I thought that I need to do an example in order to fully let you understand the process in doing or approaching this kind of problems. So apparently, let's try. It's previously was question 11, so let's do question 12. So question 12, the matrix is A equals to 2, 2, 0, and then 2, 5, 0, and sorry, and 0, 0, 3. Okay, this is 3, yeah. Okay, so apparently, the first step, complacency, be sure not to do something stupid like me. So apparently it's lambda I minus a equals to 0, and therefore, typically what I would do is this is the first step lah, okay? So I will write lambda minus 2, lambda minus 5, and lambda minus 3, right? However, now change the sign. So now 2 will become minus 2, 0, 0, 2 will become minus 2 also, and then 0, 0. So this will be our matrix for the lambda I minus a is equals to 0. So what does this mean if you were to have question mark is that this is actually this. Okay, so you're just combining lambda I minus a together as this equals to 0. Okay, so after which the second step is to find is to use the rules of Sorries. Okay, is to use the rules of Sorries to find our so-called equation so that we can solve for our lambda values. So how do we do? Okay, so how do we do? So give me a moment. I copy this matrix. I paste it over here, and then I take this 2. Okay, I take this 2 and I just paste it over here. Okay, because this is what it is lah. Okay, so apparently if you're writing it, you can actually do it in the manner. So similarly, I'll just highlight the things. So it's just this in this manner, and this. Okay, so apparently the next step you need to do is to do up all the multiplications. So lambda minus 2, lambda minus 5, lambda minus 3. So this is the first row, and then minus 2 times 0 definitely is 0, and you plus 0 times minus 2, 0. And then now we have we are dealing with the minus. Remember green color minus the blue color. So this is what it is. And then 0 times anything is 0, plus still anything times 0 equals to 0. And then we have minus 2 times minus 2 times minus 3, which is 4 times 3 equals to 12, which is minus 12. And therefore let's do up this dude over here. So we have lambda minus 2, lambda squared minus 3 lambda minus 3 minus 8 lambda plus 15. Alright, and then we'll just do it again. Okay, hold on. So we have lambda cube minus 8 lambda square plus 15 lambda minus 2 lambda square minus 16 lambda minus 2 times minus plus 16 lambda. Yes, have to be very careful. Minus 30, and then now you minus. Okay, now you minus. Minus 12 is plus 24. Okay, so this plus 24. So therefore, what do we have? So we have lambda cube minus 8 lambda square minus 2 minus 10 lambda square minus 10 lambda square 15 lambda 31 lambda plus 31 lambda, and then minus 30 plus 24, we have plus 6. I have a feeling that I'm going to be wrong, but yeah, let's continue first and see whether am I really wrong. So now we are doing the third step. So we are using the synthetic division. Okay, so as I say, we take out all the coefficient. Okay, this is 1, and then minus 10, 31, and 6. And then I think I have really something is wrong somewhere. Hold on. Lambda square minus 3 lambda minus 5 lambda plus 15. And then lambda cube minus 8 lambda square 15 lambda minus 2 lambda square 16 lambda minus 30. Okay, so this is what it is. Minus 5. Okay, never mind, let's continue first. So let's guess any eigenvalues. So let me guess 6. Okay, so let's 6 times 1 is equals to 6. So therefore minus 10 plus 6 is equals to minus 4, and then minus 6 times minus 4 equals to minus 24, 7, 6, and definitely I am wrong somewhere. You give me a moment, I go and do it out. Okay, I found my mistakes. Okay, so apparently when I draw the arrows, okay, just be careful that don't forget to see. I took the minus 3, but it's actually lambda minus 3. So therefore, the last equation should be let me see. So then minus 4 times lambda minus 3. Okay, so it's minus 4 times lambda minus 3, and this dude will become minus 4 lambda plus 3. And then after that, when you put, because it's like that, right? So it is minus in terms of this, so it will become plus 4 lambda minus 3. Okay, if you were to now go over the, okay, so apparently once you have this, let me see, it should be correct. I think it should be. I may be wrong again. Lambda cube lambda. Oh my. Okay, so apparently lambda cube minus 8 lambda square minus 10 lambda square, and then 15 lambda plus 16 lambda, we have 31 lambda, 31 lambda plus 4 lambda plus 35 lambda, and then we have minus 30, minus 33. We are wrong again. Definitely we are wrong again. Hold on. Okay, calculation error. So apparently we should have this form. Let's calculate the, later I will show you why, since I already on the video. Let's calculate whether is it correct or not. 6 minus 4, 20, minus 24, 3. Oh damn, somewhere is wrong again. Okay, when you're doing a lot of math, you're going haywire. So apparently plus, everything is due with this, okay, everything is because of this, okay. So apparently, let's redo it again, okay. What the hell? Okay, so apparently plus 4, okay, because minus 2 times minus 2 is 4, positive 4 times lambda minus 3. So we will have 4 lambda minus 12. And then since it's negative, minus 4 lambda plus, hold on again, 12. Okay, that's cool. So let's rewrite the equation. Lambda cube minus 8 lambda square plus 15 lambda minus 2 lambda, I'm gonna find my copy again, minus 10 lambda square plus 31 lambda minus 4, 27 lambda, and then 30 minus 30 plus 12 is minus 18. Okay, so apparently let's do syntactic division. We take the coefficient 1 minus 10, 27, and minus 18, and then bring the 1 down, okay? Every time you just bring the first coefficient down to 1, and then you just guess. Let's guess 6 again, because my answer sheet is 6. So then you just do 6. And then 6 times 1 is equals to 6. And then it will become minus 10 plus 6 equals to minus 4. And then minus 4 times 6 is equals to minus 24. Add up together, you have 3. And then you just multiply again, you get 18 equals to 0. So we set. Okay, so I previously in the last video I talked about if you guess 2, right? If you guess 2, and then you will not get 0. But however, 2 you will get 0 also. But what I want to give another example is, let's say if we guess a wrong number. Okay, let's guess. From here we can know that 6 is a lambda, is a eigenvalue already. Let's guess 7. Okay, let's guess 7. So let's say if you want to multiply again, 1 times 7 equals to 7, minus 10 plus 7 equals to minus 3, and then minus 21, 6, 42, you can see that this is not 0. Therefore, this is not an eigenvalue. Okay? So, once you get this, what you do is to write this thing. So this is, you decompose it into a lower order. So therefore this is lambda square, okay? Coefficient is 1 lambda square minus 4 lambda plus 3. And then you just decompose it again. So you will have lambda minus 1 and lambda minus 3. And therefore, since we know that this is the first guess, okay, first guess, lambda, okay, the first guess. So we know 3 will finally, therefore our 3 eigenvalues are 6, and then the roots, okay, 1 minus 1 equals 0, so that lambda is 1, and then 3, okay, so we have 6, 1, and 3. And then I think let's just stop here, and then we will just continue in the next video for doing the eigenvectors. Okay, so see ya.